Hi, you're listening to Naked Neuroscience, the podcast exploring the workings of the brain and the nervous system in our bodies and beyond. I'm Katie Haler, and this month...
Migraine is a very invisible illness, and people often don't understand how debilitating the pain can be. Some people will dismiss it as just a headache, just take an over-the-counter medicine and you'll feel fine. But migraine is a very complicated biological process.
We're back on headaches, looking specifically at migraine. What's going on in the brain when a migraine's happening? What causes them in the first place? And what can be done to help? But before that, as usual, it's time to crack open some naked neuroscience news. With friends of the show, psychologist Helen Keyes and neuroscientist Duncan Astle. And this month, Duncan's been thinking about jobs, sedentary behaviour, and cognitive health.
So I've been working at home now for 3 or 4 months, and it's been a pretty sedentary experience. Most days, wearing my pajamas pretty much the whole day.
You're not supposed to admit that, Duncan.
Everyone knows
supposed to hide
it's true.
like everyone else.
And it got me wondering, what's the relationship between the kind of lifestyle we have, in terms of how sedentary or how active it is, and our cognitive health across the lifespan? And that's what this paper is all about.
Okay, so what did they do then?
The story starts a long time ago, back in the 90s, when about 8,500 people were recruited from their GP surgeries, so the general practitioner, in Norfolk. And they were originally recruited, and a whole series of measures were taken, including 2 physical activity questions. They were asked to rate their physical activity during work and their physical activity during leisure. And those measures were actually validated by fitting heart rate monitors to people and checking whether or not they really correspond to physical activity, and they do. Fast forward to about 2006, just over 10 years later, subjects are all seen again. And part of the measures that they're given this time around include a cognitive battery. So a battery of different attention, memory, reasoning, language tasks. And then what the researchers wanted to do was explore whether how active you were just over 10 years ago during work and during leisure is predictive of your cognitive health more than 10 years later.
So what did they find out then?
They found, somewhat counterintuitively, that if you're more physically active in your job, that's actually a risk factor for poorer cognitive health more than 10 years later. Conversely, if you are more physically active during your leisure time, that's actually a protective factor for cognitive performance more than 10 years later. So there's no simple relationship between more physical activity equals better cognitive health later in life. The type of physical activity seems to be much more important.
So what's going on? Is it that if you're more active in your job, perhaps you don't do the same level of activity in your leisure? Because I can see why being active in leisure time is good for your brain, but I can't really see why being active in your job is bad for your brain. Or is that not what they're saying?
So the devil's in the detail. It's not that being physically active at work is bad for you, not at all. The point that they raise in the paper is that the kind of job you do is much more complicated than just is it physically active or not. So there are all sorts of other wider socioeconomic factors that also are predictive of the kind of job that you have. And we know that some of those are also associated with cognitive health across the lifespan. So for example, if you are on a lower income, then that is a predictor, a risk factor for poorer physical and cognitive health across the lifespan. That also correlates with whether your job is more manual or more office-based. All these kinds of socioeconomic factors come into play and might be really what's driving this apparent relationship with physical activity.
But is there anything positively sort of protective about having a desk-based job?
So they do say that having a desk-based job reduces your risk of poorer cognitive health more than technically. So there is something protective about having a desk-based job. But again, is it having a desk-based job, or is it all the things that are associated with it? For example, maybe earning more money, having more secure employment across the lifespan, and being less stressed in that respect. Are these the kinds of factors that are actually driving the better outcomes for those individuals? There are all sorts of factors like that it could be.
It sounds like what you're saying is it's probably a question of privilege, right? If you've got more money, perhaps you're more likely to have a better education, therefore a higher paying job. Maybe it's a desk job, and maybe you have more means to enjoy active leisure time outside of work because you don't have two jobs. Is that a fair statement to make? Because I know it's quite a general statement.
No, but I think that what you're essentially touching on is that socioeconomic status is what's really driving these relationships. And that's what they allude to in the paper.
And that is such a massive factor that it outweighs the potential physical activity benefits of doing a manual job.
Exactly that. Because we do know that if you control for those things and you look at people's cardiovascular health, then that does predict better cognitive health over the lifespan. So if you have better cardiovascular health, so for instance, like lower blood pressure, then you find that people do better in terms of their cognitive health. We do know that being more physically fit and healthy does predict better cognitive performance. But in this paper, because they're looking at the type of job you do or how physically active it involves you being, what they're actually revealing is the kind of privilege that's enjoyed by people who have more sedentary, well-paid, desk-based jobs.
There's quite a lot going on in this paper. What do you think that people should take away from it?
I think that people should not be distracted from the idea that being physically active is good for you. I guess it also would make us think that even if your job is physically active, that doesn't mean that you shouldn't also try and be physically active in your leisure time.
Thanks, Duncan. And that paper was published in the International Journal of Epidemiology. Now to Helen, who's been looking at a paper asking whether sleeping with a partner, just sleeping mind you, rather than any other activities, has any impact on the quality of your sleep, particularly rapid eye movement or REM sleep.
It's where the good stuff happens, consolidating our memories. It helps to resolve some emotional distress. It also leads to increased social cognition. So REM sleep really ties in with a lot of improvements in people's lives, including having a positive effect generally on mental well-being. So REM sleep is really where it's at. And this study wanted to look at what's happening with REM sleep when you co-sleep with a partner. It was a sleep lab study. In this case, they were measuring EEG, so looking at the electrical activity in participants' brains when they were sleeping. They asked 12 heterosexual couples to come in over 2 weekends. And on one of those weekends, the couples slept in the same bed together while their electrical brain activity was being measured. And in the other weekend, they slept in separate beds in separate rooms in the sleep lab. That same electrical activity was measured again. The couples also completed questionnaires about their relationship quality. So the depth of their relationship, the amount of conflict in their relationship, the support they felt from each other, and also got to complete the passionate love scale about their relationship.
Were these couples people who slept together normally?
Couples who'd been together for at least 3 months in a situation where they were sleeping together every night or almost every night for the last 3 months. So yes, there were certainly couples who did normally sleep together. Tended to be rather young couples, so the average age was 23, but they were in fairly solid committed relationships. And the authors found that the couples spent a higher proportion of sleep time in this REM sleep when they were bed sharing compared to when they were sleeping alone. This REM sleep that they engaged in was also less disrupted, so better quality when they were sleeping together. So that's really lovely. They found a really nice effect that might explain why they had more REM sleep. They found there was greater synchronization of sleep cycles when couples slept together, more so than when they slept alone. This synchronization between your sleep cycles was strongly correlated with the depth of your relationship. So the deeper your relationship was, the better the quality of your relationship, the more synchronized those sleep cycles were.
That's very cute.
That is very cute, I agree.
What about deep sleep? Do we know if this has any effect on the other bits of sleep? Because I know REM sleep is really important, but it's not the only type, is it?
It's not the only type, and we generally go down through stages of sleep. So when we talk about, the architecture of sleep, you're going down from, stage 1, stage 2, stage 3, stage 4 into deeper sleep. And it tends to be after that very deep period of sleep that you can then go into this REM sleep. But these periods of actually quite high electrical activity in the brain, that's what's happening during REM sleep, they seem to be really key to people feeling that they've had a good sleep. So if you are just engaging in other types of deep sleep, you don't feel as refreshed, you don't feel that you've had as good a sleep, and continually depriving people of REM sleep, even if you're allowing other types of deep sleep, can lead to quite serious psychological problems. It's just really essential to humans and other animals that we engage in this REM sleep.
As we're such a social species as humans, I can see the logic of why, having a closely bonded relationship and sleeping in the same place would be good for your sleep. But do we know what's actually going on to make it that way?
We don't know. So it could be that, you just feel safer when you're sleeping with a partner, and that would tie in nicely with the correlation with the depth of your relationship. That makes sense from an evolutionary point of view. If you feel safer, you can enter into that deeper sleep cycles. And then the other aspect that could be driving it is this synchronization. So if you have a deep relationship with someone and your sleep cycles are somehow synchronizing with each other, perhaps that just spurs a better rhythm of going in and out of these sleep cycles. We don't quite know why, but that synchronization seems to be key to both people getting a better night's sleep and getting more REM sleep.
Do you think it could be influenced by just what you're used to? Because sleep, for me, is associated with routine. I have a sort of bedtime wind down routine, and I'm just wondering if these couples habitually sleep with their partners in a study when you're sleeping by yourself, it might just feel a bit weird and you might just sleep worse.
It's absolutely a good hypothesis. There has been other research looking at people who are single and how they sleep. That's a great question. And we have found in the literature that people who are in couples generally sleep better and report subjectively feeling that they've slept better than people who are single and sleeping alone. So that research has been done, but I don't think it's been done in this detail, looking at actual electrical activity in the brain. Because REM sleep is so associated with this social cognition and sociality, it's really interesting that there can be kind of a positive spiral happening here. The authors say it's likely that this has a really nice effect. You sleep together with your partner, you have more REM sleep, which in turn leads to more positive mental health and more pro-social behaviour and your willingness and ability to engage in social behaviour, which can be obviously very nice for a relationship. It also would make you think twice about perhaps, sleeping on the couch if you're having a fight with your partner, because that potentially could lead to worse sleep, less sociality, leading to less sleeping together altogether. So it does seem to have a nice positive pattern there, sleeping with a partner.
What do you do if you're in a really deep relationship with someone but they snore and it's a nightmare for you?
You're in a conundrum. So what was really nice about this study, they didn't find any results specifically around snoring, but this may be because they looked at participants who had an average age of 23. So I would suggest they come back in 20 years and look at these data. But they did look at body movements during sleep. They found what has already been established in the literature, that people who co-sleep engage in more body movements during the night. But really nicely, they found that didn't affect the quality of sleep at all. So that's lovely. So even though people are being disturbed more from that physical movement of a partner in bed, it's not affecting their sleep quality or the amount of time they spend in REM. Now, the same, I imagine, couldn't be said of snoring. I think that's a whole other study. And I really think if you're fortunate enough to have a partner who snores, you're going to have to weigh this one up carefully, I think.
Thanks, Helen. And the paper we were musing over just then has come out recently in the journal Frontiers in Psychiatry. And we've linked to those papers, as usual, on our website, if you want to read more. So the references and interview transcripts can all be found at nakedscientist.com/neuroscience. And if you've got a question or some feedback for us, you can email neuroscience@nakedscientist.com.
Welcome to the Naked Gaming Podcast with me, Chris Barrow.
And me, Lee Milner.
Every month we look at the latest gaming news.
Because we've been really locked away all the time. This gave me an outlet and somebody to talk to and actually talk about things that are going on.
We review the biggest releases.
If it's like a film, forget it. I'll watch a film. I just want to get in there, shoot some baddies.
And because there's a simulator for almost anything, we play some of the strangest ones available.
The best thing is you can set off without letting everyone on, just like a real subway underground driver. Yeah, mind the gap, you idiot.
The Naked Gaming Podcast from The Naked Scientists. Download it now wherever you get your podcasts.
Music in the programme is sponsored by Epidemic Sound, perfect music for audio and video productions. And last month we dipped our toes into headachy waters. So for the rest of the episode, we're diving a little deeper into this subject. Back in June's episode, neurologist Amanda Ellison took us through the various stages of migraine headache. And this month I wanted to find out a bit more about what's actually going on in the brain. So first up, here's an interview with Anna Pace, a neurology academic and also a headache doctor from Mount Sinai Hospital in New York.
The most common headache syndrome that we see in the office is actually migraine. And I think primarily that's the case because the pain is so debilitating, affects people's ability to go to work, go to school, attend social activities. And a lot of people also experience other symptoms with their migraines aside from the debilitating pain. And that's really what brings them to the office because it makes them concerned that maybe something else is going on or they don't understand why it's happening.
What is happening in the brain of somebody who is having a migraine?
Oh, that's the million-dollar question that we're all trying to figure out is what exactly happens in the brain when you have a migraine. In the past, it was thought that it was a blood vessel type of disorder or vascular type of headache was the term that was used, meaning that the primary reason why people had pain was because blood vessels dilated. And what we now know is that it's actually a much more complicated process than that and a very biological one. And so what we seem to understand is that for some reason, people with migraine have a very irritable or excitable brain. So their cerebral cortex is hyperexcitable. We don't understand why that is, but in the brain, the neurons are triggered to fire when they're not supposed to be doing that, or they're fired kind of inappropriately, and they set each other off kind of like a domino effect. So one neuron starts to fire, then the next one goes, and the next one goes. And so all of a sudden, all of these nerves are activated, and then it's followed by a wave of inactivity or what we call cortical spreading depression. And as that happens, there are chemicals that are released in the brain that cause inflammation, which then lead to the blood vessels dilating and pain being experienced. So it's actually a very complicated interplay between the electrical activity of the brain as well as blood flow. Now, that's kind of the mainstay pathway that we think happens with migraine. But to be perfectly honest with you, the more and more research that we do, the more we understand that there may not actually be other pathways that are a little bit redundant, or they cross with this particular type of pathway, which could explain why certain people have some symptoms of migraine versus others, or maybe why certain treatments work better for some patients than others. So I think it's a very heterogeneous type of pathway, and patients really experience it differently, even though we still use the term migraine.
It sounds really complicated. Do
It
we
is.
know what's happening right at the beginning when you said you have nerves firing maybe inappropriately? I think you said. Why is that happening?
That we don't seem to know. I think primarily we understand migraine to be a genetic type of disorder, or people with migraine have a genetic predisposition. So for some reason their brain is wired in this way to be hyperexcitable. This is kind of the area of research that people are really looking into, because we don't understand why some people have this and other people don't. Obviously it does run in commonly in families, but it seems to be some chemical imbalance in some of the electrolytes that flow back and forth through the nerves, but we don't understand why that is for some people and not for others.
What's going on with aura? Because when I was speaking to Amanda Ellison in the previous episode, I mentioned that I'd had, I think, only 2 migraines in my life, but I just felt this massive sensory overload. Lights, noises, it just made me feel utterly awful. And I got all these splodges in my vision. Why do some people get this sensory overload? And why do some people not?
I actually get aura as well. And this was one of the main reasons why I wanted to go into headache medicine, because I just could not understand why this was happening. So we use the term aura to mean the neurologic symptoms that come prior to the pain that people experience. So commonly, people will experience squiggly lines or zigzags in their vision, kind of looks like a kaleidoscope. It may start in one spot, get bigger, move across their vision. Some people will get a tingling, almost kind of pins and needles sensation, followed by numbness. And some people actually notice their speech change. And that's really a result of the activation followed by the wave of depression. So depending upon which part of the brain is active, some people are a little bit more sensitive to that pathway than others, because the brain is being activated. For example, in the occipital lobe, which controls your vision, you may start to see things that are not there. Then it goes away as that wave of activation starts in the back of the brain and moves forward. Occipital lobe gets activated, you see things, and then it goes away. As it hits the sensory cortex, you start to feel the pins and needles sensation, and then that goes away. If it hits the cortex involved in speech, you may have some difficulty finding your words or being able to say the word that you want to get out. The sensory overload component, because the brain is using up all of this energy on this process that's going on, any type of stimulus, light, sound, smells, movement, almost kind of overloads the brain, and it can't function in the same way because its energy is being used up during this process. And so people often want to be in a dark, quiet room, and really any type of stimulus is just so incredibly uncomfortable. And as the headache continues to progress and the pain starts to resolve, people often feel what they call a migraine hangover.
When you were talking just then about speech difficulties, that seems quite scary to me, because that sounds like a stroke. Is there any relationship between what's going on in a migraine compared to in a stroke, or am I barking up the wrong tree?
No, that's actually a really great connection that you made. There is some data to suggest that people who have migraine with aura specifically are, especially women, are at a slightly higher increased risk of stroke compared to the general population. The risk is still very, very low, but it is something that we do counsel our patients about. For patients who experience aura, it can be incredibly scary because it's this transient neurologic symptom, especially speech. I think my patients who have speech changes in particular always get very anxious when this happens, because sometimes you don't know, is this just my migraine or is this something else? Normally with migraine, it tends to be progressive. It starts, it gets a little bit worse, and then it goes away. And it's very stereotypical. So people who have migraine with aura often report to us that they have the same type of symptom each time they get a migraine. Stroke tends to be much more quick in onset. So you're fine 1 second, and then all of a sudden you have a speech problem. But in certain patients, especially older ones who've never had migraine before, who develop some kinds of symptoms like this, like a speech change or even weakness on one side or tingling or numbness, sometimes it is important to go to the emergency room for an evaluation for stroke, because that's the thing you don't want to miss. More often than not, it's not a stroke, but it can be very scary for the person who's experiencing it.
What can you do for people then who are experiencing migraines? I just hid until it went away. I don't know if that's a good thing to do.
We want to prevent them from coming in the first place. And then we also want to treat when a patient gets them. So the treatment really depends on how frequent the attacks are happening. Some people experience an attack once a month. Some people may experience attacks 15, 20, 30 days out of the month. And so the treatment really depends on how frequent the attacks are happening and obviously how much they affect the person's usual routines. Medications are often commonly used. Non-medication options are available as well. Often lifestyle modifications are important. So staying very well hydrated, getting good sleep, not missing meals, exercise, stress reduction. It's amazing how much some of those things can actually really affect how frequent your headaches are. They tend to reduce the frequency. There are a lot of devices that have been released that have been helpful for migraine prevention. A lot of these treatments really look to target certain parts of the pathway that we know occur in migraine. And so a multimodal approach and a multidisciplinary approach is often really important to use.
Could you target what the nerves are doing at the beginning and maybe the vasodilation? How does it work?
Yeah, so a lot of the medications that we have work on different parts of the pathway, and we've had many new medications that have recently come out that have targeted something we newly discovered is a key part in the migraine pathway. Often combining certain treatments really give you the best benefit in terms of headache relief, especially from a prevention standpoint. Because again, since everybody experiences this a little bit differently, it may mean that certain parts of the pathway are much more active for someone than others. And so really targeting more than one area will give you the best likelihood of feeling better. A lot of the medications that we use for migraine originally were borrowed from other classes of medicine. And they essentially were found to be useful for migraine because during the trials for, say, for blood pressure or antidepressant or anti-seizure, the patients who had headache and noted improvement. So some of the medications that we borrow from other classes of medicine really act on kind of the later parts of the pathway. We do have 4 new medications that were recently approved for the treatment of migraine that have come out over the last few years that target one specific chemical called CGRP, or calcitonin gene-related peptide. This is a chemical that's inflammatory and is released when you have a migraine, and it does tend to lead to vasodilation. So this particular treatment works on trying to reduce that chemical. So it's a little bit earlier on in the pathway that we tend to use and find that patients do well and have a reduction in their headache frequency when they're on these kinds of medications.
What about transcranial magnetic stimulation? We've talked about it on the podcast a little bit before. Does this have any relevance to migraine?
It does. I actually find this incredibly interesting. So transcranial magnetic stimulation's been around for a very long time, but really only started to be used for migraine, I would say probably over the last 10, 20 years or so. It's non-invasive. For most people, from a migraine perspective, it's a portable type of device. And what it does is it essentially creates an electrical current around the head, and it is painless. We think it helps to reduce that wave of activation and depression, the cortical spreading depression we talked about, and also helps to reduce the hyperexcitability of the brain that we know is the beginning part of the migraine. And the studies that we have for TMS found that more than half of the patients actually had a 50% reduction in their headache frequency and no side effects.
Is it safe?
Yes. It's been around for a very long time, was originally used for anxiety, depression, is actually still used for that purpose. It sounds kind of scary, but it actually does work very well. And I have many patients who do utilize this type of therapy and do very well. And I find in particular, and the studies have shown this as well, that patients who do have migraine with aura seem to respond well to this particular type of treatment, primarily because I think it's affecting the cortical spreading depression part of the pathway. And that's really the thing that drives the aura.
What does it look like? I'm imagining that you wear some sort of special hat and then get zapped. What? Maybe that's completely off. What does it look like if you're having this treatment?
So there are a lot of different kinds. The one that is used for migraine is often a single pulse, and it is a portable device that kind of looks like a rectangle with two handles on the side. And people use it in the back of the head, kind of almost like it's kind of like they're using a scarf. Like if you were to pull it around the back of your neck, except you'd put it up to the base of your head. And there are two buttons on the side that you would hit.
Looking forward, where are the areas that need work, or the areas of unmet need in headache medicine specifically?
Primarily understanding a little bit more about the headache pathophysiology is important. Like we talked about, why is the brain so hyperexcitable in the first place? Why do certain patients respond to some treatments when others don't? Is there just this one pathway that we know about? Are there multiple redundant pathways? And I think understanding really what happens in the brain can really help people create more targeted treatments. And we know, these last 4 medications, the CGRP antibodies, have really paved the way for new research looking at targeted therapies. And coming up in the pipeline are other chemicals that we have found that really do trigger migraine attacks. So in theory, I think the areas that we really need to work on are creating more targeted therapies, maybe more individualized therapies related to the information we find as a result of this research. And also, there are certain patients who aren't able to take certain medications that we have available for migraine, whether or not it's because they have another medical problem that will not allow us to use it, or if they're on other medications that will interact. And so just having some more treatment options that are safe for those patients, I think, is really the other area of unmet needs that we really need to address.
Anna Pace, thanks very much. That was Anna Pace from Mount Sinai Hospital in New York. And as we mentioned, Anna is a headache specialist. And over here in the UK, the National Health Service website explains that the National Institute for Health and Care Excellence, NICE, recommends that transcranial magnetic stimulation for migraine should only be provided by headache specialists in specialist centres because of the uncertainty about potential long-term side effects. The NHS website goes on to say that evidence for the effectiveness of transcranial magnetic stimulation in migraine is not strong and is limited to people who have migraine with aura. If you want to find out more, I've linked to the NHS website's migraine page in the references section for this interview. Check out nakedscientist.com/neuroscience and look for this episode's page. And the visual disturbances that, as Anna mentioned, can be associated with migraine are particularly interesting to me personally because it's something I've experienced. So my interest was piqued when I came across some of the work on headaches and some visual aspects of the built environment. Arnold Wilkins is a psychologist from the University of Essex who's interested in these visual disturbances. And he told me there's rather a lot of the brain devoted to what we see, and that the brain has evolved to process natural images. This, he says, can cause a bit of a problem when we're asked to look at a lot of unnatural images. Spatially repetitive stripes, for instance, which means the brain needs to work a bit harder, and the resulting headache can be quite a pain.
A student of mine took photographs by standing at the side of the curb and aiming the camera across the street somewhat randomly. And we were able to analyze the images using a computer algorithm written by my colleague Olivier Pinaccio, and we were able to predict how uncomfortable people could find these images. All the algorithm did was to measure statistically how unnatural the images were. Some are more unnatural than others, you see. The worst patterns are probably those in the escalator stair treads that you get in department stores and the underground.
But they're everywhere.
They are, yes. These patterns and stripes are there partly because of the way we build things, so they're a component of modular construction, but they're also there as decoration because designers, for some reason, seem to like them, which is unfortunate. Because, I mean, for example, I could give you an example. There was a large, brand new bank built. One senior executive at the bank wasn't able to work in the new building because it was decorated with stripes, and she happened to have migraines.
No.
And she fortunately for her, was sufficiently high up to be able to demand to retain her original office.
You said repetitive shapes and you also said stripes. Are those the culprits, or are there any other defining characteristics that cause a problem?
We can define them mathematically using Fourier analysis, which is a bit complicated to explain, but basically looks at the world as if made up of lots of sine waves in different orientations and different wavelengths. And by analyzing those using a simple algorithm, we can predict discomfort. We can explain a surprisingly large proportion of the variance in judgments of discomfort from such a simple algorithm. It's interesting because all the algorithm is doing is effectively saying how unnatural is the image. It's the images that make the algorithm go off, as it were, are particularly stripes, but anything that's spatially repetitive, they don't have to be obvious stripes. If you look at a modern office block, we'll easily do it.
That sounds like quite a big problem, because if you're consciously visually aware of something that looks uncomfortable, at least you can try and take some sort of action. But what it sounds like you're saying is that you can be unaware.
Yes, largely. We're not usually aware of what causes headaches. I did a study a long time ago which showed that fluorescent lighting caused headaches. In fact, it doubled the number of headaches that office workers experienced. We compared the flickering type of fluorescent lighting with what was then a modern flicker-free type, and none of the participants attributed their headaches to the lighting. But when we changed the lighting, the headaches halved. So people really don't know what triggers their headaches. It may well be something visual that they're not aware of.
Do we know what's going on in the brain to make them uncomfortable? Has anyone stuck someone in an MRI scanner and watched them watching images?
Yes, and what you find is you get a very large hemodynamic response. We've done two types of measurement, one using fMRI and one using near-infrared spectroscopy, and they both showed the same thing. In the visual part of the brain, you get a lot of activity that you can measure in terms of the blood oxygenation demand from the neural activity, clear neural correlates of the discomfort people experience.
And how does that turn into a headache, though?
How? I'm not sure. We do know that there are substantial changes in oxygenation during a headache, and we know that the sort of visual stimuli that provoke a large hemodynamic response are also those that people say give them a headache. Quite how the trigger happens, I'm not sure yet.
Arnold explained there's a huge variation in how susceptible people are to these kinds of headaches. But his previous study found that the more illusions experienced, all sorts, changes in colour, movement, etc., when you look at these stripes, the more susceptible you seem to be to these headaches. And what's more, this may be a particular issue for people who suffer from migraine with aura. As Anna Pace was saying earlier, aura are the squiggly lines of visual disturbance that some people experience with a migraine headache. So, what can actually be done about these stripe-inducing headaches? Because we don't always have control over what our environments look like. Maybe you can paint your bedroom a different colour if it's bothering you, but redesigning a local office block is a whole other ballgame. Back to Arnold.
I think it's fair to say that architects are becoming aware of them now. And interested in them. It is quite unnecessary to decorate buildings with high contrast stripes. And indeed, some architects have gone so far as to get gardens to grow up the side of buildings. And that's a very nice way of overcoming some of the aggressive architecture that you otherwise get. There are things you can do about your susceptibility other than changing the environment, which is to change your local environment, your vision, by wearing coloured glasses. This may seem very strange.
It actually doesn't seem strange at all, Arnold, because I have prescription glasses because I'm too scared to wear contact lenses. But my sunglasses are brown tinted. And I always love the summer because I get to have my brown tinted glasses. Life looks nicer, to be honest, through them. But sometimes when my eyes are tired, I wear them inside. And I must look like an idiot. But I do, because when I'm looking at a screen, I feel better. It doesn't seem strange to me.
Well, we've just done a study. This was done by Alex Vara, who was a student of mine. She asked individuals with migraine with aura, and she asked them to look at text in an apparatus that I designed a while ago called the intuitive colorimeter, which just allows people to change the color of light falling on the text and to vary it systematically in a controlled way so that we could overcome the effects of color adaptation and so on. And the interesting thing was that all of the individuals who had migraine with aura chose a very strongly saturated color, a very strong color, very different from one individual to another. But when we gave them glasses of that color so that they could get that colored light under normal illumination, their ability to search for words in text was greatly improved. When we gave the same task to individuals who didn't have migraine or had migraine without aura, no such choice of strong colors. Everybody chose the colors they would normally experience in everyday life. So from a yellow through to a white, through to a bluey white from the sky. So there are huge differences in the choice that people with aura, migraine with aura, make as compared with migraine without aura or headache-free people. There's a clear link between migraine with aura and colour, which is curious, and we've got to explore it further.
Do you know what's going on?
We know that when people wear a colour they find comfortable for looking at things, the size of the hemodynamic response in the visual cortex is reduced. In migraine, one of the early findings was that people with migraine have an abnormally large hemodynamic response in the cortex. The brain was measured using fMRI, and you look at something called the blood oxygenation level dependent signal, and that was larger than in headache-free individuals in response to certain patterns. When these individuals with migraine with aura wore coloured spectacles of the choice of colour they found comfortable, that abnormal response was reduced, it was normalised. Whereas when they wore coloured glasses with a different colour, there was no such reduction. So the colour choice is critical. It's only when you get the colour right for the individual that you get these beneficial effects.
Arnold Wilkins, thank you very much. There's so much more to understand about colour in the brain. And if you want to delve a little deeper with this podcast into how the brain processes colour, then check out our Colour on the Brain episodes from February and March 2020. You can find them, as with all of our episodes, at nakedscientist.com/neuroscience or wherever you get your podcasts. And that's all for this month. Thank you to Arnold, thanks to Anna, Helen and Duncan. Join me in August for more Naked Neuroscience, but until then, thank you very much for listening and goodbye.